Okay, let's do some sample problems that are going to involve some problem solving here with rates. Let's get right down to it. Contextual problems, isolating variables, all that good stuff. Sandra works for 23 hours every 3 weeks. Okay, Sandra, we've got 23 hours. How many hours will Sandra work in 1 year? So 23 hours, 3 weeks, is going to be how many hours in 1 year? Well, I think 1 year is 52 weeks, more or less. So I guess we'll cross multiply here and we'll get 3x equals 23 by 52. And then we divide by 3 on both sides of the equation. And we're going to get x equals 398.7. So how many hours? I'm going to guess 399. 400 hours. Looks good. Alrighty, what else we got here? Ruprecht, oh, nice name, wants to buy 100 liters of bottled water. Store number 1 is 15 kilometers from his home and sells cases of bottled water for 20 cents per liter. Store number 2 is 20 kilometers from his home and sells cases for 15 cents per liter. Where should Ruprecht buy his water? Costs 15 cents per kilometer to drive his car. Okay, let's see. Let's do a scenario for each one. Let's go store number 1. So at store number 1, it says it's 20 cents per liter. So using a multiplication strategy, 100 liters multiplied by our rate, which is 20 cents. Per liter is going to cost us $2. $2 worth of water for Ruprecht for 100 liters at, no, it's not, it's $20. Holy smokes, do some arithmetic. $20 for 100 liters at store number 1. But we also have to account for his mileage. So for Ruprecht's mileage there, it says it's 15 kilometers from his home. So let's look at his car cost here. Let's call it car cost. So it's 15 kilometers and it costs him $1.15 per kilometer. So we'll take our 15 kilometers and multiply by our rate. So 15 cents per kilometer is going to be $2.25, I believe, if I'm not mistaken. So 15 times 0.15 is $2.25. So in total, if Ruprecht buys his water at store number 1, it's going to cost him $22.25 for 100 liters of water. Crazy, isn't it? Okay, store number 2. Okay, again, it's 100 liters multiplied by the rate. And for store number 2, the rate is 15 cents per liter. So we're multiplying by 0.15 per liter. So that's going to be $15. Okay, so it's obviously cheaper just to buy the water. But if the extra distance makes up enough for us to quit, I think we're going to have to go with the other one. I don't know. How much is this going to cost? Car cost here. Okay, so in this case, we've got 35 kilometers for Ruprecht. And Ruprecht's a nice name. So he's going to travel 35 kilometers at 15 cents per kilometer. Okay. And 35 times 0.15 gives us $5.25. Which gives a total cost for that store of $20.25 using a cost analysis. It's cheaper for Ruprecht to drive the extra 20 kilometers and buy the cheaper water in this case. All right, Ruprecht, go for a drive. Several strategies that can be used to solve rate problems. Ratio and proportion is good when we saw that. Cross multiplication gets us there. Sometimes we could use a linear equation to solve for for a missing quantity. You'll see that in your textbook. I find that usually more confusing. So I know when I teach this course, my students typically don't do that. So it's usually a little bit harder. Don't tell anybody I said that if they're trying to teach you that, though. And it may also be feasible to solve such a problem using reasoning, multiplication, division logic, all that stuff. Hope that's helpful. Good luck.